Hey everybody, welcome to our InfoWorks Bridge workflow presentation on the Pattullo Bridge project. Today I have Danny Lewis with me in Saskatoon. I'm in Vancouver. We are working at Hatch, and we are working for Acciona and Aecon on a project in the Lower Mainland here. We'd like to give a special shout out and thanks to Era Ashikian and Chris Landry, who were instrumental in helping us through this process. Era really knows his stuff, and he was willing to help us at any moment's notice. He always responsive, and Chris was always looking for people to help us if we needed help. I'm sure Danny has some things to say about Era.
Yeah, like we could not have done this project without their help, and we really consider them as part of the team for the whole project.
Definitely part of the team.
So, quick disclaimer on what you're going to kind of see in our project. It's still in process, and so there's little glyphs and issues on it. We're aware of them. It's the fact that it's not done yet, and we wanted to get things out by mid-August here. So, next slide.
So the project is located about 25 kilometers east of Vancouver, British Columbia in Canada. It is a new bridge build. In the foreground here, you can see the new bridge, and the old bridge is this early 1900s bridge that will be demolished. In the background, we can see a SkyTrain bridge for rapid transit, and down here you can see an old rail bridge that's still in use. So we've spent in the BRIM team, that's me and Danny and a few other people, almost 3,000 hours learning this process, troubleshooting, testing it, figuring out how this bridge workflow works in InfoWorks. We're using Inventor, InfoWorks, and Revit, and we spent, roughly only 14% of our time in InfoWorks modeling. A lot of it was spent building parts in Inventor, and a little bit was spent in Revit, putting the models into Revit. Here's the list of software we use. You can read this at your leisure, but the gist of it is you want to use the latest software you can get. 2021 minimum, but there's a lot of fixes in the 22 stuff, so preferably the newer stuff. We had a few issues along the way, Danny.
Yeah, it wasn't, as I say, rainbows and lollipops. We had lots of issues. Some of it was software, some of it was just learning issues, some of it was Civil 3D, and then the solution was always the same, which was just to spam Autodesk with as many emails as we could. And again, they were very helpful for trying to help it. They didn't address all the scenarios, so we had a lot of fun as we were doing this. And it is a really fun program to play around with. So.
Yeah, I love this program. I mean, it was so much fun. There was challenges, but using the software was fun, which helps during difficult times when you're challenged. So,
yeah.
First part, yeah.
As we mentioned, like trying to do this in other kind of softwares like Revit alone or Inventor alone or anything else alone, it just would not have worked. So.
Yeah, I'm a solid Revit user. I would not have been able to do this in Revit alone. There's just no way. So the first step of the process in Civil 3D, we need the Civil 3D corridors from the road team. That's kind of what drives this whole bridge, which is great. You need those corridors. You basically bring them into InfoWorks. And once they're in InfoWorks, they kind of control the bridge. So I've got a few slides here I'm going to flip through, and you can read them later. But I really want to highlight that if your corridors are not perfect and have little errors like this in the surface, it translates underneath the surface to the deck and the bridge structure, the steel, and it causes problems underneath there, which are quite significant. You can see that little gap that you saw on the top caused this with the girder and this with the deck underneath. So you want to refine your surface corridors as best you can to avoid these little problems. So we're going to jump into a video now of adding the corridors into InfoWorks. It's really not that difficult at all. You're basically going to go into InfoWorks, and we have, in this model example, 29 corridors. 29 corridors of roads and MUPs and walkways. And I've left this video, this part of the model, missing one of the corridors. I'm going to demonstrate bringing that in. We're going to bring in the actual raw Civil 3D file, which contains the corridor in the source model. And up at the top, we're going to go to manage the data sources and bring up the window on the right. And we're going to browse for the Civil 3D file. in BIM 360 on your desktop connector. I'm going to browse for that L100 corridor file. That's the file that hosts that corridor. I'd like to remind everybody that it's really important that you have at least Civil 3D 2021 or 22 on your machine. Your working files don't need to be working in there. They don't need to be that version. Inforx uses the latest version of Civil 3D in the background to process these files when you bring them in, and it takes a while, upwards of 30 minutes per R files, 29 hours to do all of these, or 16 hours to do all 29 files. It was crazy, but it's well worth it. Pick the roads only. Don't pick the surfaces on each file. You got to select what elements you want to bring, and this is picking the roads. So you pick the roads, and the bottom right, it says that it needs to be configured, or it is configured. No, it needs to be configured. So you press configure. It's a bit confusing. I've complained to Autodesk about it and hinted it needs to be reworded. But you configure it, and this again takes a little bit more time for this window to show up. Check for errors and choose the corridors that you want. There may be multiple corridors in one file, or there may be reference corridors. You don't want the reference corridors. You want the raw corridor in that file, okay? Check for errors. There is some errors there, which I know which they are. Those little triangles there, they're errors in Civil 3D. Refresh and close. And again, this takes more time. So this whole process, start to finish on one corridor, will take about 30 minutes for this corridor. Your corridors may be different. And there you have it. There's the L100 brought into the file. Now, we're going to move on to, hey, when you have an update, because we know the roads are going to update. We know that the road people are going to move the road around. We know they're going to change the location of the bridge a bit. Hey, not a big deal, because this software accounts for that. We can update. Cool thing is we can update the bridge in Inforx with the corridor. It's so cool. So I've got a few tips here on what, some pointers on what you can do. And we're going to launch another video showing me updating one of the road corridors in the file, which again can be a bit time consuming, but it's definitely worth the wait. You basically go to the data source listing again, and we're going to find that corridor data source listing here, the L3500 off ramp here. Okay, we check the last date that it was maybe put into here. You can check your network, BIM 360 or ProjectWise, whatever you're using, and when it was last done. Watch this area in here. There's going to be a change here and a repair of this gap. Refresh does not reload the data. It just refreshes the data in the model and rebuilds the structure. You want to re-import the data to get the updated new data from your source model. And yes, it's grayed out, but it's actually a functional button. It kind of looks like it's grayed out and it's confusing, but press that button and you'll wait again. And watch this area in here. You'll see this gap. Oh, you're going to get reference warnings on the other screen or at the bottom, which are warning you about failure to gather references. This will happen if you have X references or data shortcuts, data shortcutted elements in your host file. It's just telling you it can't find them. For us, those files are in ProjectWise. If they're in BIM 360, I have a feeling it'd be able to find them and you probably wouldn't get these messages coming up. We just ignore them because we know we only want the source data in that file. And as you can see, I've definitely sped this up. And there it is. It's all fixed. That gap is fixed based on the new corridor. And I also like to check by highlighting the corridor or highlighting the data source over here. I like to check the configuration and make sure there's no warnings or errors. And also make sure that if the civil team added some corridors, I could add those in as well, or additions to those corridors or offshoots. Again, we only want the one corridor related to that is the L3500. I don't need the other ones, but they might add some 3500 elements to there that I might want to bring in. Update that, close it, and you're done. Now on to Danny and the cool inventor stuff.
Yeah, so none of that Civil 3D garbage.
Hey, hey, hey,
Um,
hey, not
so
stop knocking my Civil 3D.
once you have the, I'll just take control of this now, Scott. So once you have the corridor set up, the way InfraWorks is going to do is it's going to use that to drive a bunch of models. And the models it creates from are origined in Inventor. Most people in the AEC world have never heard of Inventor, and it's just some foreign software. Why don't I just use Google SketchUp? But it is a very, very powerful software, arguably way better than Revit for capabilities. And if you don't know Inventor, you should just feel sorry for yourself because you're so missing out on this. So the next
It's
slide.
not that bad. Come on.
Yeah. Okay. Next slide. So with Inventor and InfraWorks, essentially you're going to be making parametric models. And the only trick you have to kind of watch out for is that you have magic words that you need to have that InfraWorks will recognize. You'll build the models that you've got your parameters that I change the parameter and the model changes. Once you publish it into InfraWorks, InfraWorks will take control of those parameters and then drive those parameters for your model. There's either magic words to do or a list of prependings. And again, I'll try and put a little bit better of a summary for that because it's a bit of a dark magic for each one. So we'll just click into the video. So this is, this is how fast I model because Inventor is so great. But this is the whole workflow. If you want to for yourself, you can slow it down, but we're trying to keep for brevity of time. One thing that we found was helpful is we'll make a skeleton model where we put all the rest, the information that InfraWorks is going to drive and put that as the sketch, and then build our components on top of that. That way we know they're going to move, they're going to have all the prependings named correctly, and it's going to interact the way we want it to. It's unfortunate, it's different for every single type of component you're going to make. So if you're going to make a girder, it's got kind of rules to it. If you're going to make cross braces, abutments, piers, etc., you kind of almost have to learn each one as a separate, different kind of trait to it. But in any sense, with Inventor, for anyone who's not familiar, you pick a plane, you put some sketches on it. You're going to create a bunch of different parameters, and then later on, you're going to then tie those parameters to the sketch. And that way, the parameters, as you see here, you just give a bunch of different names, mark them as a key column, and then those are what gets exported into InfraWorks. Now, the challenge with this is always naming something that will make sense to somebody else who's picking it up later. So here I'm just calling it the right girder RSTHK. You'd hope that the person who's using this next would understand what changing that parameter would do in the model. And that's a bit of the challenge. So the way that's addressed in InfraWorks, later on, we'll see that they have a tooltip thing that you can put into it. But again, that was a bit clunky in InfraWorks. So we ended up building that tool into Inventor itself, and then we can adjust it all. So here I'm just kind of still putting in the geometry. For everyone who also isn't familiar with kind of like parametric modeling in Inventor, it's not like AutoCAD where I draw a rectangle with specific dimensions. I will draw the shape, and then I'll define the rules that create that shape. So I'll create, these two parts are collinear to each other. These two lengths are equal. And then those rules are what actually drives the geometry in it. So because of the rule-based kind of system and your ability to put toggles and do programmatic controls to it using iLogic, it's an incredibly powerful software that you can make almost any shape under the sun that you can imagine into here. And as well, the iLogic rules that you would create in the Inventor models, or the ability to kind of toggle things on and off, do translate into InfraWorks. There's some limitations that you can't use all the iLogic capabilities, but for the most part, you get everything you need to. So here I've put all the components in, and now I'm just kind of putting it back to the default locations. Here is kind of our homemade app that we made where we're putting in the descriptions for all the different things and making it nice and clean. You'll see later on how these import in, but this saves a lot of time and it keeps a little bit with the model for coordinating. As well, within Inventor, you can easily just put things into a spreadsheet format and then adjust the variations of things in that spreadsheet. So in this instance, I have the option to turn the left or the right or just individual stiffeners on as I need to. And then I can create any other variations of that, and then it's all published. So that was quick, but again, you guys can slow that down as you need to. The next step is then once I've got it published, it'll create multiple different kind of files that carry with Inventor file, and then you would publish it into InfraWorks itself. Okay, go ahead with the next slide. We'll just kind of walk through that. Yeah, so once you get into InfraWorks, it's not intuitive. This slide is just kind of something to refer back to later. They don't have it quite as a live connection. So unfortunately, once you put a part into there, if you want to go and change it and add some parameters to it, you have to go republish it, re-put it in there, swap components to be the other ones. And you have to push the import button a couple different times in different places in the right order to get it work. So it's not as intuitive as it could be on the InfraWorks side, but it's still very good. Go ahead. So here's the video of me kind of putting those components then into InfraWorks. One thing is for the parts like cross traces where they pre-penned onto a different component, they kind of have to be a matched set. So as an example, say I have the parameter ABC123. Well, the girder has to have ABC123 so that the cross braces can have left girder ABC123. And so they kind of have to go as a paired set. If I put my cross or the stiffeners that I put in onto the generic cross or beams, they just wouldn't interact with each other because they would have different parameters and they wouldn't see each other. So you put the component in and then you kind of label what type it is. There's a little previewer at the bottom, but it's garbage. And then here I'm showing us importing the JSON files that we created with our app. And it brings in all the tooltips and the labels nicely. And then same thing here, it pops in all the sizes. And then I've got it. To put them in, there's lots of tutorials about it, but you essentially click cross frame. It will kind of stupidly put in as many cross frames as it can fit into that area. And then you have to go in and change the number down to 1 if you want 1. And then wait, and then you go and then you change it back to the specific size of the stiffeners that you want. So then it's in there. And then you can change any of the parameters that you've described and tagged to there. And then the model will start to adapt to it. And as well, if I change the beams, then everything will then adapt from that. So that's it.
Yeah, thanks, Danny. I mean, that's part of the cool part about this whole thing, and the parts that come out of Inventor and into InfraWorks. All the parameters in Inventor come into InfraWorks, and you could change them there and adjust the piece, and let InfraWorks adjust the piece as the girders move up, down, left, right, the spacing of them. Those pieces will flex with everything. They'll adapt, which is really important. Now you have a lot of cross members that you saw there. You can imagine a large bridge with lots of cross members or lots of splices and splice plates or girder depth heights change. Guess what? We can send that to a spreadsheet and edit it in spreadsheet. We can edit most of the parameters in the spreadsheet. We can change a lot of different things. And I was going to say, you know, a lot of people can work in this model at the same time. What? Are you kidding? Yes. Cool thing about this, more than one person can work in InfraWorks at the same time, which is very similar to Revit. And as long as those people are working on separate alignments, not the same alignment, but working on a bridge on a separate alignment, multiple people can work on bridges and sync. It's pretty cool. Definitely great at collaborating and working in the one model.
Yeah, and we've even found with the spreadsheets that you can have multiple people working on the same bridge as long as they're all just manipulating spreadsheets.
Yeah, you could have people modeling and people working on spreadsheets at the same time at different spreadsheets, and I'll go over that in the video about how to do this. Here you see an example of a splice plate, a different girder depth change there. That's all done in the spreadsheet. You can do it in the model if you like. It's a little bit more time consuming. You got to do one at a time. You know, so you see some girders and some braces here and some more splice plates, and it's up to you where you want to do it. There's some tips here. I'll leave that for you guys to read. You can adjust the cross brace locations based on the station offsets. And now we're going to play a video showing how to get the structure into the spreadsheet. It's not too difficult. You click on the structure that you want to put in the spreadsheet, you right click, and you say send to spreadsheet. Create a new spreadsheet. Name it, save it in a logical location that you can find it later. It will open in Excel for you. and you can start editing the parameters there. What Danny was talking about with multiple people, you can have people working on another spreadsheet and pasting that data into the spreadsheet you just opened. And that's what we're doing here. We're copying it out of another spreadsheet and we're literally pasting it into the spreadsheet that I just created from InfoWorks. You could go and paste line by line, you can paste cell by cell, you can do a whole sheet, as long as you've got the same number of rows and columns and they've all got the same order. You want to remove extra data that's at the bottom, save it, exit it. You go back into InfoWorks and you click on the bridge. This might be a bit confusing, but you send a spreadsheet and update existing. I know that sounds weird, but it is send a spreadsheet and update existing. Made a few comments about that to Autodesk to maybe fix that terminology. And we found that shaking the screen is very helpful. You should try it. It does speed the process up, as you can see here. Once it comes in, you'll see the girder depth change there. Right there, you've got two different girder depths. Now you can see that the cross frames are very close together. We need to space those out. So we're going to go back to Excel and edit this cross frame spacing there. And again, the person that did this for us, they had another spreadsheet that they were working on while we were doing the modeling. And we're just taking the data from that spreadsheet, pasting it into the one we just extracted, populating the data there. We did learn that formatting is very important, and that black text did cause a problem. Formatting, it needs to be blue in the same font or it won't work. Then when you bring it back into InfoWorks, you just say update existing and you wait. And you'll notice here that it's slower because we're not shaking the screen, but you can do pier foundations, pier caps, abutments, bearings, element names. You can fix up all that stuff in the spreadsheet.
Everything that's in blue is editable. Yep.
Yep. And here you can see this, the spacing on the cross frames is now expanded out. Now, I think one of the coolest things that we've been waiting for decades, or not, some of us have been waiting, is that we can now get our really nice models into a place where we can detail them, where we can annotate them, put dimensions on them, create views, put the sheets on. Yes, we're still delivering drawings. We're not delivering a BIM model of the bridge to have somebody build it. We still need drawings. What I like about this process is that these models and drawings in Revit are tied all the way back to the corridor through InfoWorks. It's all tied back to that corridor, and the adjustments happen as you make changes along the way. So in Revit, we'll import what's called an IMX file, which is a file that was created for this process, I think, by Autodesk. And we import that into Revit, and we can also import the changes and get updates from InfoWorks as many times as we want. And you'll get notifications in Revit telling you that the changes have happened if you want to update. And that just blows my mind. It's just like, what? This is amazing, right, Danny? I mean, you've got a corridor in Civil 3D that changed, which then changed the InfoWorks model, which then changes your Revit model, and thus changes your drawings. You don't need to model multiple models anymore.
Yeah, and I think that Autodesk accidentally made like the superpower system with InfoWorks, because you're knitting together Civil 3D, Inventor, and Revit all together in a one cohesive system that's editable. So
I find it's what we've been waiting for. At least I've been waiting for it for 10 years. I tried to do this about 10 years ago, and this is the key. So one of the things that you'll notice when you get a notification update, it looks like this in Revit, and you can either apply or ignore the update. Say you're in the middle of a submission, you're going to do drawings in the next couple of days, you don't want the update, you can just ignore it and do your annotations and get your package out. So we're going to go through importing into Revit, and you start in InfoWorks again, and very similar to the spreadsheet, you need to publish the structure this time instead of export the spreadsheet. Publish the structure, name it, this IMX file, name it, save it somewhere. You're not going to lose it. You remember the location because you have to go get it. This also takes a bit of time. It's not too bad, but it takes some time. It creates 3 files, an IMX, a JSON, and a log file. In Revit, we're going to look for that IMX file. But first, we're going to start with a template. So we're going to start a container file to house that Revit model that we're going to create. One key thing is we want to start the shared parameters and create an empty shared parameters file. It's very important that it's empty. Okay. We're going to go to the add-ins, import civil structures. We're going to look for that IMX file. We're going to bring that IMX file in. And boom, the structure is there out of InfoWorks. And the shared parameters are populated with all of the parameters from the InfoWorks model and from the Inventor model.
Yeah, and that part right there, you can almost stress again, because it is every single parameter for every single component in the entire bridge will then come in as something you can tag into Revit.
Yeah, I think it's with this case, it's the used parameter. So if is one that's not used, it won't come in. But yeah, it's just, it's amazing. Honestly, I still amazed by it. I've been doing this for over a year in this process, and I'm still amazed by it. Now, what about updates? Because we all know the structure changes, right? The corridor changes, the structure changes. You might change the spacing on something in InfoWorks. Well, you can re-import the changes into Revit. So you export the IMX again from InfoWorks as an update. It will update that previous IMX file and the JSON and the log file. In Revit, it's as simple as opening that Revit container that was housing that Revit model. And we did one container for each structure, and then we created a combined file. You are then asked to apply or ignore the changes because it recognizes the change in the IMX file. You apply those changes, and well, what does this look like in the model? Let's take a look. Keep an eye on the upper right-hand side of the structure. We apply the changes, and you'll notice, in this case, I updated the corridor, and it changed the super elevation and lowered the super elevation on the top there. Pretty cool, huh? The whole structure moved. Everything moved with it. Another view of it at a pier, which has bearings and pedestals for those bearings. Watch the pedestals, they adjust as the top right corner drops. Watch the pedestals. And it did take 45 minutes, but it's well worth the change. To do this would take days, if not weeks. Watch the 3D model. All of the structure changes, the bracing, everything drops.
Yeah, and for anyone who's familiar with like making components like that in Inventor, this is thousands of components that then just get automatically updated to exactly what they're supposed to be in reality.
Yep. We actually just did that change last week, and we were a bit nervous because it'd be the first time that we did a very large change like that. We weren't sure if it was going to run all night, all day. We had no idea what was going to happen. I was worried it would crash, but 45 minutes later, it adapted. So pretty impressive, pretty impressive. Here's some images from the InfoWorks, or the Revit model. You can see the detail in it. We actually even have SAG, or Danny put SAG in the cables, the correct SAG. Precast deck panels. You can see the precast deck panels underneath, the bracing.
We had rebar in there too, but that started to be a bit
Yeah,
much for it, so.
That's a good point. We had rebar in the precast panels, right? And it was a bit too much detail. Now we want to get the Revit model into Navisworks so we can clash detect and coordinate with the utilities models, any utilities models or other structural models from other groups that are done in Revit. The surface, you can see it all there. It's actually really easy. It's not a big deal. We're really just going to reference in the RVT Revit file. It's super simple. In Navisworks, you're going to append the Revit file, the same container file, use the same container file that you're working on. In Revit, you have to create a 3D view and name it Navis. Okay, so name that Navis. You also want to remove some of the extraneous data. You want to get rid of topography, Revit links, annotations, anything in that view that you don't want to see in Navisworks. So you're left with just the raw structure. You save that file, rename it the view to name to be Navis, and Navisworks will pick up that view name. when you insert that or append that Revit file. So here we're browsing for the exact same working file, the container file, and updating an existing Navisworks. You can see here the surfaces for the bridges, which is traditionally what we've had in Navisworks. We haven't had structures like this for bridges. We've had surfaces from the civil team. So it's great now. We have the structures in there. It creates a NWC file for you in the same folder that your Revit RVT file was in. And when you want to update that, you just replace, you just re-update, reload in Navisworks, and it just updates. I mean, I think the whole workflow is amazing that we can do this now. So we have one final video here for you to show you the working environment that we're actually working in. And there's no rendering in this video.
Yeah, that's the crazy part. Like InfraWorks is originally developed as a concept models. So yes, you can do all this powerful kind of bridge manipulation and interaction, but it's also just pretty. And you can put trees and bushes and waters and plains. And again, so this is a part of the recording software that's integrated into InfraWorks, but you can stop at midway, and this is exactly how it appears as you're in the InfraWorks model manipulating things. And later on in here, we show selecting a bridge, and then you'll see that, no, this is the bridge that you're selecting. So this is the detail. I mean, obviously, if you're smart, you wouldn't turn anti-aliasing and reflections and shadows on
Yeah.
not all the time, because that might hurt your computer. But all the details there, you can see all the nuts and bolts, all the cross.
It is amazingly fast though, isn't it? I mean, in InfraWorks with this much detail, you can flyer and move around the model quite quickly, for the amount of detail.
Yeah, and one of the things that InfraWorks does is it'll actually detect like how close am I looking at a component, and things like trees where it's got lots of definition at a certain distance, it doesn't bring it in for resolution. Once you get closer, then it brings in a more detailed model.
This all started about 1.5 years ago. Somebody comes to me and he says, "How would you like to model the Pattullo project in Revit?" And I said, "No way. There's just no way we can do it. I know Revit well, and it would be so complex and difficult, and I'm not sure how we would do a lot of it." And a few months later, Era gave us this demonstration in the office. I said, "Wow, that's the ticket. I think we can do this now with this software and this workflow of combination of software." Because I knew Inventor, I knew Revit, I knew Civil 3D, and I knew a bit of InfraWorks. And here you can see the detail in that MUP overpass, pedestrian overpass. It's just beautiful. And without this, we couldn't have done it. To do this in Revit, it would have taken us years. I feel like it would have taken us years.
Mm-hmm.
Anyway, that's it. Thank you very much for watching. We appreciate your time. I'm Scott Cameron in Vancouver with Hatch, and I'm joined here I'm the mastermind of organizing this group, and Danny Lewis is our inventor guru in Saskatoon and his team.
Yeah, and so on our team, we've got an intern who's been invaluable, so Kristen Berry, who has just brought lots to the team. And then we brought on Daniel Jeffrey, who's also really skilled at inventor and programming, which has helped. Millie Jameson came on as a summer student, and she helped us a lot with the spreadsheet work.
In Vancouver, we had Glenn Farage, our Revit Sith Master, helping Emily, our Revit Padawan learner.
And we also had a high school student, summer student, help us out, and he was also doing some XML editing and other little odds and ends for us too.
And none of us were exposed to this workflow over a year ago, right? I mean, we learned all of this in the past year.
Yep.
Each person contributed to the software in their own way. And sure, one person could do this, right, Danny? Like if you had a small bridge and you knew all the software like I do, I could do a simple bridge. But with a large complex of bridges like this, it's best to have specialists in each group. And the stuff that Danny did in Inventor was invaluable. The automation, the iLogic stuff is fabulous. It's just too much to do for one person. So yeah, I appreciate this team.
The other thing is, like, now that we've done this one bridge, we are definitely taking this show on the road, and we will be using this for other kind of future projects we have at Hatch.
Yeah, we got a few other things. We've got some tunnels and some more bridges.
some birth
rail
dolphins or
bridges.
whatever. Yeah,
And some other secret stuff that we can't talk about.
it's cool.
Thank you very much, everybody.